Hi students, good evening to all of you, and as you're preparing in the final moments in between your board examinations, you're preparing for the different subjects. I know in 17th it is your maths paper, isn't it? The CBSE students. So in between, whoever are preparing, putting in a lot of effort, we are also trying to give our best so that we can upgrade your preparation for the JEE mains to be held in April. All right, so let me see who all are there in the session right now. I can see Rishi, good evening. Gautam, Shalini, I have Ashutosh. Yes, so awesome, friends. Okay, so today's topic, as you were saying to me, as most of the students were writing to me, sir, you have done a considerable amount of your 11th standard, right? 11th standard, we have finished the entire of mechanics. All right, part of the properties of fluids which is left. Okay, so we'll do it together. Whenever we do properties of solids, we'll combine it with properties of solids and liquids. All right, so we will start off with the 12th standard syllabus, that is your electrostatics. Now electrostatics as such is a very vast topic, right? So we won't be able to do a justice if I just take one class in electrostatics. Rather, we are going to have two sessions on electrostatics. In the second session, we will do more of questions on electric potential, the work energy theorem based questions, and also some questions on your capacitors. All right, however, lot of content that I have already done, okay, in the special classes of the Plus platform in your circuits. So if you're wondering and if you're thinking that you want to revise your circuits, all right, specifically circuits, you can visit those special classes in the JEE, that JEE Plus platform. All right, so students will get started off right away. All right, good show. 14 people are watching here. Yes, numbers are increasing day by day. That is awesome. Can I have the like counter also going up in the meantime? Sure. So all of you who are watching me live for the first time, my name is Sumit Kundu. All right, I'm a BTech graduate from IIT Bombay in civil engineering. I passed out in 2007, and since then, well, for a short span I was into the corporate sector, and after that for the last 10 years I have been teaching, coaching, mentoring, guiding students to achieve their goals and dreams to reach out to a premier institute of this particular country. All right, so here we are with you people to guide you and also motivate you to your dreams at the same time. Okay, so students, next thing is the tinyurl.com/JEE mobile. Well, a very important link for all you students, because why? Because if you have missed on any of the sessions in the last year, you would want to revise. This is where you need to go to, tinyurl.com/JEE mobile. Okay, and students, if you haven't taken the Plus subscription, quickly go ahead, take in the subscription and use the code SMLIVE. All right, now students, in today's session, oh, by the way, what is going to happen if you use this code? You're right away going to get a 10% discount. That means currently, instead of 36,000 for 2 years, it is 32,400. But using this code, you get a further 10% discount, so it becomes 27,000. All right, so that is a benefit. Do not miss out on this particular opportunity, students. Okay, now let me get started off with our today's session. Some very interesting questions are here. So what I'll do is, initially I'll explain to you whatever the question is telling, and then I'll give you a chance, okay, of let's say one to 2 minutes, so that you can solve it during that particular time, or just think about the question in that particular time, and then we will go ahead with the discussion of the problem. Okay, so we will get started here. We have two identical point charges. All right, so what do we have? We have two identical point charges. So let's say this is one charge and this is the other charge. All right, say this is plus q, so the other charge will also be plus q, and the distance of separation between them is equal to L. Fine enough. Okay, now P is a point on the line joining the charges. So let me take any such point here, call it as my P. So P is the point joining is present on the line joining the two charges, okay, and it is located at a distance of x from one of the charges out here. All right, now the field at P is given as E. The field at this particular point P is being denoted as E. All right, now they have plotted the graph between this electric field and x. X is varying between 0 to L, and electric field is plotted against this x. So you need to find out which one of these graphs is currently representing the variation of electric field with the distance. Question is pretty clear, okay? The situation is given to you out here. L is the distance, x is the point where you are finding out the electric field, and now graphically you need to actually understand which is the correct answer. So can I see some of the question right answers coming from your end? Time, I'm giving you 2 minutes. 2 minutes to solve this particular question. All right, so go ahead, think about it, okay? Well, yes, who is this? I can see Nirvi Parik. Nirvi Parik, you have cracked it pretty well. All right, the correct answer is indeed B. The correct answer is indeed B. Let's go ahead. We have got very less time and we have got too many good questions today. Really nice questions today to solve. So we will not waste any further time, okay? And right away go to the discussion. See, generally for these kind of questions, what is recommended? There are two methodologies which are recommended, okay? Number one, you can do it analytically by looking at the graphs by the elimination method. Number two, you find out an expression for the electric field as a function of x, okay, and then try to see that which graph would best represent this particular function. All right, so there are two methods. Now the easier method, or let's say the most time saving method, is basically the analytical method. All right, now let's try to understand this. Let's try to understand what is happening in this particular scenario. Let me take more area so that we can discuss this better. So we have got two charges. I have got a plus q, I have got a plus q. This is the distance x, all right, which is point P, and here we are trying to find out the electric field, okay? So let me say this is the center. This is the center, that is the center of the line joining the two charges out here, okay? What is going to happen at the center? We will first try to understand. Now, this point here, the electric field due to this charge will be in this particular direction, and electric field due to this charge will be in the opposite direction. This electric field, we'll call it as my E1. This electric field, I'll call it as my E2. All right. What will happen at the center? At the center, your E1 will be greater, sorry, not greater, obviously, it will be equal to, because the electric fields are going to cancel out at the center. So at the center, E1 will be equal to E2. Simple enough. This is pretty easy to understand, okay? What is going to happen in between the first charge and the center? Because this point is closer to this charge, so E1 will be greater than your E2, okay? So in this particular region, E1 will be greater than E2, and E net is basically E1 vector plus E2 vector. I think this is pretty clear to you, okay? Now we are doing it analytically, we are not writing down any expression whatsoever. All right, so try and understand that E1 is greater than E2. That means E1 is in the positive direction, E2 is in the negative direction. E1 is greater than E2. That means the net electric field will be positive between 0 and this L by 2. Now, as you take any point out here, I mean, you shift this point P to this particular place here. Here, your E2 will be greater than E1. And E2 is basically in the negative direction and E1 is in the positive direction. E2 is greater than E1. That means the net electric field is going to be what? Negative between L by 2 and 0. That means the electric field is in the positive direction between 0 to L by 2, and from L by 2 to L it is basically in the negative direction. So we can actually cancel out some of the graphs out here. Okay, so we can see that option D cannot be possible, because in option D electric field is always in the same direction, that is it is always lying above the x-axis, right? In option A also electric field is always above the x-axis. So option D and option A is out of the picture. Okay, now here in B and C, yes, electric field is taking positive and negative values, but let me consider a point which is very close to the origin. Okay, which is very close to the charge here. So when you bring a point very close to the charge, okay, we know that electric field E1 then will be kq upon x square. Now x is tending to what? 0, which implies your E1 will tend to what? Infinite. Now here it is having a definite value, it is not tending to infinity. So option C cannot be the right answer. Option B is the correct answer. We didn't have to find out an expression for the electric field at a general x, but rather analytically if you do it, you will get your answer. Alright, so students, those who have understood it, please go ahead and press the like button right away. Now, are you interested in more graph problems? Let me see the response. Yes. Okay, fine. So let me take another problem, and this is based on graph at the same time. Okay, now let me explain to you the question what is here. Okay, now in this particular case what we have is, let me draw the axis first. Let me draw the axis. Who's going to read out such a long question? Let me explain to you right away. Okay, what is there in this particular question? See, on the y-axis, at a distance of a, and below here at a distance of a, I have put two positive charges. So plus q here and plus q here. Okay, there is another charge. Okay, there is another negative charge. Clear? Which is actually going along the positive x-axis. Right? Now they have mapped the acceleration of this particular charge versus the x distance, whichever position it is. All right, they have tried to match the acceleration of this charge against your x. You need to find out which will be the correct graph, which will talk about the variation of the acceleration with the x, that is the x coordinate, wherever the charge is actually moving. Okay, I hope the question is very, very clear. So all of you take 2 minutes. I see already the answers are coming. The answers are coming. And let me say, Neerav, that's not the correct answer. Shalini, no, that's not the correct answer. All right. So students, that's not the correct answer. A is not the correct answer. Let us try to understand it. Now we will do one thing. We'll take a fresh page here and try to explain to you that what exactly is happening. Okay, now see this. I'll draw the x and y axis at this particular point. Let me choose a different color here. So you have plus q here and a plus q here. You take a point out here. Now let's say this minus q is located right now at this particular point. Okay, now because it is minus, this is plus, the nature of the force will be attractive. The nature of the force is going to be attractive. So also will be this force be attractive. If this is F, this will also be F. Okay. So at any general x, at any general point when it is at a distance of x from the origin, okay, let's say it is making an angle of theta. Okay. So if this is F, the net force in this direction, F net, will be equal to 2F cos theta. Because the sine components, if you see, they are going to cancel each other. Sine component of the forces are going to cancel each other. So the net force is equals to 2F cos theta. Okay. Now let's see 2 and what is F? Coulomb's law. Very simple. Okay. So this will be K Q square divided by this distance from here to here. Okay. Let me call it as my R. So this will be R square. And what shall be cos theta? Cos theta, very simple, it will be x divided by r. cos theta will be x divided by r. Now observe what will be the value of r. What will be the value of r? Pythagoras theorem in this particular triangle. Okay, so r will be root over x square. Let's say this distance from here to here is actually equal to a. All right, they are equidistant, right? They are equidistant. So I can write the value of my r as equal to root over x square plus a square. Yes or no? Yes, absolutely. So this expression is going to look something like 2kq square x divided by x square plus a square to the power 3 divided by 2. Okay, so this is the expression of the net force. So acceleration will be what? I can write down the acceleration as equal to this entire thing divided by the mass m. Okay, now using this particular result, we can find out the expression or the relevant graph. Okay, so I hope you would remember this. Now let's move ahead and write down this expression here. Acceleration is equals to 2kq divided by m x square plus a square to the power 3 divided by 2. Okay, so now let's go ahead and analyze the graph. Simple enough. See, whenever we get these kind of expressions, all right, and we have to look at the graph, we use the boundary conditions method. That means what will happen to the value of acceleration at x equals to 0? Number one. Number two, we will look at the value of acceleration when x tends to infinity. All right. So these two boundary conditions, it's a generic method. All right. So let me put the value of x to be infinity. So x is much greater than the value of a, right? So if x tends to infinite, all right, then acceleration expression, you try to see here, x square will be much greater than a square, right? So I can write down the denominator as simply 2kqx divided by m into x cube. 1x will cancel, this will become square. Infinite. So acceleration will become equal to how much? Will be equal to 0. Acceleration will be equal to 0 as x tends to infinite. All right. So let us try to see. Option D will go away here because as you are tending to infinity, it is getting a constant value. It's not equal to 0. All right. But here in option A, option B, option C, they are still in the contest. Okay, now let me look at the other boundary condition. Okay, let me look at the other boundary condition. Let me take my x equal to 0 and see the value of acceleration. Put the value of x equals to 0. What will you get the value of acceleration? 0. Simple enough. Okay, now if I take this as 0, so my option A will also go because at x tends to 0, acceleration is infinite. So this is also gone, right? Acha, now another thing, analytically we will do it. Okay, try to see the diagram right now. Try to see the diagram. Now when in this region, when x was negative, acceleration, net force is in which direction? F net is actually along plus positive x-axis. Right? And when my charge will come here minus q, then try to see that this force and this force will give me a net force along the negative x-axis. Clear? So if you look at the graph right now, so in this region it is positive, in this region also it is positive, in this region it is positive, in this region it is negative. So I think you are smart enough to figure out that option B would be the correct answer. All right, hope everybody has got it. All right, chalo, go ahead and press the like button if you have understood this particular method. Now we will go to some more interesting and challenging problems. So you are ready for it? Okay, let's go to the next question. I love this problem. Okay, it's very interesting, very short. Okay, let me give it a star rating. Of, let's say, 3. Star rating, like I mean to say the difficulty rating. Okay, out of 5. Okay, this question has a difficulty rating of 3. Now what is this question saying? that it's a ring. It's a ring of radius r. Okay, so you have this ring and it has got a radius r. Now what happens is you take away a chotu sa portion, like very small portion of this ring. Acha, by the way, before taking away the small portion, let me give it a charge q. Very nice. We'll give it a charge q. We'll give it a charge q. This charge q is uniformly distributed over the entire ring. Arey wah, this ring looks so beautiful now. Okay, now this ring has been given a charge plus q and it has been distributed over the entire ring. Okay, what you do right now is you take away a small portion of the ring. Now this portion has got a length d. Okay, this portion has got a length d and you actually take it away. Then there are the other options. What are the options? In which direction the electric field will be now? In which direction the electric field will be now? Second thing, how will the electric field be proportional to r? Whether it will be inversely proportional to r cube or whether it will be inversely proportional to r square. So let's see answers coming from my students. Okay, Nirvi has answered B, Shalini has answered B, Deepu has answered B as well. All of you are wrong. Okay, it's very sad to say, but yes, that's the reason why it's got a good star rating. Okay, anything 3 and above is a good question. Good star, 3 star and above is a good question. All right. By the way, someone with the correct answer. Deepu Rana first said, now what is going on is tukka baji is chilling. Okay, so chalo, let's not have tukka, let's not have just wild guesses. Okay, let us try to understand the question right now. Okay, now as such, acha, by the way, the correct answer is option A. So your guesses will stop. Okay, so right now what we will do is, it's not a very difficult question. Okay, it's a conceptual question. This is the center of this particular ring. Okay, now try to understand, if the charge is uniformly distributed over the ring, okay, what will be the electric field at the center? The electric field at the center, all of you will agree, it will be equal to 0. Okay, it will be equal to 0, right? Now let's see this portion. Let's say the electric field generated due to this one is E1 and the electric field generated due to rest of the ring is equal to E2. Clear? At the center, I am talking at the center, electric field due to this particular small portion that I took away, due to this portion at the center is E1 and due to rest of the ring it is actually equal to E2 at the center. So what is the net electric field at the center? The net electric field at the center, I'll call it as my E, which will be equal to E1 plus E2, and this should be equal to what? 0. Isn't it? This should be equal to 0 because we know the electric field at the center should be always equal to 0. So the electric field out here is how much? Is equal to 0. Okay. Now let us try to understand what is the electric field due to this portion at the center. Almost a straight line. Okay. The electric field, now it's a small portion, right? So I could consider this as a point charge. Okay, I could consider this as a point charge. So due to the point charge, the electric field will be in this particular direction, radially outward. Okay, so can I say my E2 vector will be equal to minus E1 vector from this? Yes, I can say it. That means due to rest of the ring, the electric field will be directed towards the gap. This is very clear because a lot of you have also said option B is the correct answer. So you understood that it should be towards the gap, not away from the gap. That part is very, very clear. Okay. Now let's try to understand this. Another ring I have, same ring but a different explanation. So let me now take it away from this portion. Okay. Now what will be, now you saw that E2 is equal to minus E1. So if I take the modulus on both the sides, it will be nothing but equal to the modulus of E1. Okay. Now E1, I'll take it as a point charge. I'll take it as a point charge. Let's say it has a charge delta Q. Now this Q, whichever you gave it to this entire ring initially, that was plus Q, okay, so that plus Q got uniformly distributed over the entire length. So the amount of charge delta Q will be equal to plus Q divided by 2 pi r into the length of this portion which has been given to me in the question as small d. Alright, so what will be the electric field E1? Electric field E1, let me take it a different color, while red is good. Electric field E1 will be equals to K delta Q. Delta Q is how much? Q divided by 2 pi r into D, alright, into D, we need to take this D, divided by r square. So electric field E1 you can see is inversely proportional to what? R cube. So I hope everybody understands why option A will be the correct answer. Did everybody get it? Okay, enjoyed this particular problem? Go ahead and press the like button, students, if you have enjoyed this problem. I have very interesting problems coming up. Okay, so I want all of you, whenever you sit down for these sessions, sit down with a pen and a notebook, okay, because there might be something very interesting that you could actually note down during these sessions. Okay, chalo, let's go ahead to the next questions. Shalini, what happened? Why are you crying and howling? Okay, well, let's move ahead to the next question, students. Chalo, what do we have in the next question here? Now this is one of the very standard questions, okay, has appeared a couple of times in very old JEE advanced paper, okay. Now I generally see that, like, you know, there is a certain trend in the paper that very past, like 1980s, 1990s JEE advanced papers, whatever questions were there, now they fit very well for current day JEE mains. Alright, so what do we have here is we have a ring. Okay, it looks like a disc, but it's a ring. Alright, point to be noted. Okay, this is a ring, and some point at the center, let's say I kept a charge plus Q, okay, and capital Q was given to this ring from outside. Okay, now this small q, I displaced it a little bit. Alright, by the way, it's a plus q. No, it's not a plus q. It's not a plus q. It cannot be a plus q, by the way. Okay, it cannot be a plus q. It has to be a minus q charge. It was initially at the center. So initially the electric field at the center will be how much? It will be equal to 0. So the net force acting on minus q will be equal to 0. But what we do is we displace it a little bit towards the right. Okay. What is going to happen? The electric field is in this particular direction. It's a negative charge. It will get a force in the opposite direction. It will come back to the center, but it will not stop at the center. It will go to this side, and when it goes to this side, there will be a restoring force again towards the center. That means it is going to observe a SHM. There is going to be a SHM because there is a restoring force. All right, I am telling you there is going to be a SHM. Now what I am asking you is to find out the angular frequency, that means omega, of this particular SHM. Okay, so students, all gear up. Fine. I have some answers already coming up. The answer came from Tripurari Gupta. Okay, Tripurari. Now try and understand in option B why it cannot be option B, because option B is a function of x, yaar. Option B is a function of x. In angular velocity, you will never find an expression of x. Okay, so option B, so by looking at the question only, I can deduct option D and option B. Okay, because it's a function of x. So angular frequency, it has to be like, you know, it's a constant value, right? It cannot be a function of x. So option B and D is right away gone. So you are left out with option A and C now. Which one will be the correct answer? Yes, Satyam, if I take away option B and D, then definitely option A will be the correct answer. Okay? Why? Because we find out omega square equals to something. So omega will be root of something. That is for sure. Okay. So one thing is for sure, that by looking at the options, you can make a wild guess. Well calculated guess, not a wild guess, a well calculated guess of what could be the right answer. Isn't it? Chalo. Now let's look at it. Do you want to solve it? Yes. Do you want me to solve it? Fine. we will solve it. Okay, now for this we'll take some space in the next page. This looks bigger, right? Bigger diagrams, bigger images really gives me a good feeling. It's much better to visualize out here, isn't it? Acha, let's say I take it to a point P out here, this minus Q, I took it to this point P out here. Then what is the electric field? See, you need to know these expressions for your examinations. What is the electric field due to a circular ring, due to a disc, due to a rod? Now these should be on your fingertips. Clear? So electric field is equal to KQX divided by x square plus r square to the power 3 divided by 2. This is the value of the electric field due to a ring on its axis. Clear? So what should be the force? The force will be KQX divided by x square plus r square to the power 3 by 2. Okay. Now students, if it is a SHM, it has been mentioned in the question that it is a SHM because they are asking you what is the angular frequency of this SHM. That means they are confirmed that it's a SHM. Now in SHM, remember this displacement that you do of the particle from the equilibrium position to the new position, this distance is actually very small. Okay, this distance is very small. So I can say here my x is much less as compared to r. Then the expression of force will become equal to KQQ upon r cube into x. Now when you look at this expression, okay, see, try and understand. Electric field is along the axis, away from it, this is a negative charge, so the force will be negative. Now if you look at this expression, all right, and let me just try to find out the value of the acceleration also. So acceleration will be equal to KQQ upon r cube minus x. A can also be written as minus omega square x. All right. Acha, by the way, there is going to be a m out here. Okay. Now try to see this very clearly. We can compare these two. General formula of SHM, and in this case what has happened? Omega square will be equal to what? Root over KQQ upon m r cube. K is 1 divided by 4 pi epsilon naught. Very clear? Chalo. Option A is the correct answer. Did everybody get it? Do not forget to press the like button then. All right. Chalo. Let's move ahead to the next question. The next question is super interesting. Super interesting this question is. Okay. Very innovative problems of electrostatics. Let me tell you on this particular session. Okay, go ahead in the online space. You will not find the discussion of these problems in most of the channels who are preparing live or recorded sessions for your electrostatics. Let me tell you, let me claim this. These are very interesting problems. Okay, so what do we have here? Try to see this. Got a massless string. We've got a massless string and it is connected to this ball, let's say out here, spherical ball. It has got a mass m and a charge plus q. Okay, and it was left from this position where theta was equal to 45 degree, and there was an electric field. There was an electric field directed in this direction. Okay, you left it from here. What is going to happen? Circular motion. Circular motion is going to happen. It reached the bottommost point. So they are asking us at the bottommost point, you tell me what shall be the value of angular velocity. Okay, as it passes through the bottommost point, what shall be the value of the angular velocity? This is what you need to tell me. Okay, so guys, 2 minutes of time, 2 minutes of time. Okay, you go ahead and solve it. What do I see? Yes, that was for the last question, isn't it? That was for the last question. Chalo, let's discuss it for this particular question now. Okay, some of you are already solving it. Okay, fine enough. Let's go ahead. I'm waiting the response in the chat box. Okay, कैसे करेंगे? How will we do it? How will we do it? All right. Easy. Energy conservation. Clue, hint. Energy conservation. or we can also call it as your work energy theorem. We can do it by work energy theorem. Wait, now how will we do it by this method? Let's see. Okay, chalo, I need some attempt coming from your end as well. Nirvi is saying it's option D. Why, Nirvi? Why do you think it's option D? It looks very fascinating with that number 5. That's the reason why you are saying it's option D. Well, no, it's not option D. Option D is not the correct answer. So let's rule it out. Okay, chalo, I know it will take some time. Prashu Raj is solving. Okay, Prashu, good, you are solving right now. Okay, fine enough. Chalo, let's go ahead. That's enough time. I know it's not so easy as well. Okay, so Satyam says it's option C. Chalo, let's go ahead and discuss this problem. Okay, now this ball, as it comes from position A to position B, try and understand, as it comes from position A to position B, all right, there are two displacements. One displacement that has taken place along the x-axis, and it has also moved down, right? So this, let me call it as Sx, and this, let me call it as my Sy, as it has come from this position A to position B. Okay, now what is this length here? It is given to me as your L. All right, so this distance from here to this point here will be L cos theta, and this distance will be equal to your L sin theta. Clear? So what will be the displacement along the x-axis? It will be equal to L sin theta, and the displacement along the y-axis will be equal to how much? See, this will be the displacement, isn't it? This will be the displacement. So try and understand, from here to this point here, how much is the length? It is L, and this distance is how much? L cos theta. So this displacement Sy will be equal to L into 1 minus cos theta. Clear? By the way, the correct answer is option B. The correct answer is option B. All right. Acha, we will try to do it by the work energy theorem. Work done by conservative plus work done by non-conservative plus work done by external forces will be equal to change in kinetic energy. Are there any non-conservative forces in the entire system? Tell me, are there any non-conservative forces in the entire system? No, zero. External forces, zero. Now we will calculate what is the work done by the conservative forces. What are the conservative forces actually present in this particular system? Try and understand. We have got what? Electrostatic force. We have got gravitational force. Electrostatic force is acting in this direction. Gravitational force is acting in this direction. Electrostatic force is in this direction. Displacement Sx is also in this direction. So work done by electrostatic force will be positive. Mg is in the downward direction. Sy is also in the downward direction. Work done by the gravitational force will also be positive. All right, so what will be the work done by the electrostatic force? Now we will try to find that out first. Okay, work done by conservative will be work done by electrostatic plus work done by gravity, that will be equal to change in the kinetic energy. Work done by electrostatic will be equal to how much? Mg by q, and you multiply that by q, that will be the net force. So I can write this as mg by q into q, and what is the distance moved in this direction? L sin theta. Theta is 45 degree, sin 45 degree is 1 by root 2. So this will be L divided by root 2. Okay, so the distance moved is L divided by root 2. Clear? What is the work done by gravity? What is the gravitational force in the downward direction? It is equal to mg. Clear? So this will be equal to mg, and the displacement in the y direction is equal to L 1 minus 1 divided by root 2. Clear? Now this will be equal to how much? Change in the kinetic energy of this. Now does it have any translational kinetic energy? No, it does not have any translational kinetic energy. What does it have? It has got only rotational kinetic energy. How much will that be? Half I omega square. What will be the moment of inertia of this ball about this particular axis? It will be just ml square, right? So this will be equal to half I will be ml square into omega square. Students, now the last part has come. So go ahead, do this calculation. You will get option B as the correct answer. That's all you required to be done. Now I am not doing that part. all right, because it's going to be lengthy and we are going to waste time in calculations. Okay, chalo, some really good questions are waiting for us, so let us look at them. Now this question is like super interesting question. Okay, what is there? You've got a wheel, all right, it has got a mass of m. Okay, this wheel has got a mass of m and it has got two charges who are there at let me draw it for you. Okay, when I start drawing, or rather let me take this one only. Okay, so this charge, what I'll do is I'll try to shift the position of the charge a little bit. Clear? So I'll take this positive charge out here, I'll take this positive charge out here and the negative charge out here. Okay, let me take this as my charges, plus q and minus q. Okay, now they are saying that this is at equilibrium, this is at equilibrium, and there is a electric field E acting in the upward direction. Clear? There is an electric field acting in the upward direction. So they are asking us what will be the value of E, what will be the value of E such that this wheel is in equilibrium. If it is in equilibrium, that means the net torque should be equal to 0, right? So how do we go about? Think about it for 2 minutes. Okay, chalo, think about it for 2 minutes, then we can go ahead and discuss this particular problem. Acha guys, enjoyed the last problem? Do not forget to press on the like button if you have enjoyed the last problem. Okay, very interesting this question is. Okay, let me tell you. All right, we've got very less time left, only 5 minutes. For 2 minutes for you to solve it, 3 minutes for me to give you the solution. By the way, I have got another problem just after this, that is also a super interesting problem. Okay, so we will try to discuss it. I'll try to give you the methodology, you will solve it on your own. Okay, so let's have a look at this. First thing what we will try to do is, yes, option B is the correct answer. Option B is the correct answer. Yes, very good, Nirvi, Manthan and Tripurari Gupta. Okay, where are you guys from? Where are you guys from? Okay, if you've enjoyed this as indicated, do not forget to like, share and subscribe, students. Okay, very important. Yeah, spread across these problems and their solutions to as many of your friends as possible. Post them into your WhatsApp groups, your study groups, other places, and let it spread as much as possible, isn't it? Acha, let's look at this problem now. Okay, what are the forces acting on this system? See, electric field is in the upward direction, so force on this will be in the upward direction, QE. Force on this will be in the downward direction, QE. mg will be acting in the downward direction, mg. Will there be any other force? Well, there is another force. They said it's a rough inclined plane. It's a rough inclined plane. Okay. Now, if it is a rough inclined plane, there will be friction acting in this particular direction. Okay. Now, about which point should I find out the torque? The net torque should be equal to 0. Okay. That is summation of all the torque should be equal to 0. Now, simple idea, about which point should I find out the torque? Wherever maximum forces are acting, so that I don't have to find out the torque due to those forces. So if you look at the bottommost point, I have QE acting here and friction acting here. So to make my life simple, I will take the torque about this bottommost point, call it as my O. Okay. Now, due to this mg, now this mg can have two components, one in this direction, another one in this direction. Okay. And this QE also can have two components, one in this direction, one perpendicular to it. Okay. Now try and understand that this component of mg will not contribute anything to the torque because it is passing through the bottommost point. Similarly, this component of QE is not going to contribute anything to the torque. It will also be passing through this point O. So who all are contributing? This component of mg, which is mg sine theta, and this component of QE. All right, try and understand this angle will also be theta. Calculate it at your end. Okay, let's not spend time in calculating that. So this component will be equal to QE sine theta. Okay, so this component will be QE sine theta. Clear? Acha, what torque is this going to create? the torque created by this will be mg sine theta, and this perpendicular distance out here, try and understand this. How much is this perpendicular distance? It is equal to the radius of this particular wheel. So the torque will be mg sine theta into r. Now this should be equal to the torque created by this, which is in the opposite direction. So this will be equal to QE sine theta. Now what is the perpendicular distance? This distance, which is equal to 2 times r. Okay. Sine theta cancel, r cancel. We had to find out the electric field. Electric field will be equal to mg divided by 2 times q. So option B is the correct answer. Did everybody understand? Come on, go ahead, click on the like button, students. Click on the like button if you have understood this. All right, let's move ahead to the next problem here. Okay, what do we have here in this particular problem? Let's try to understand. Well, I'll give you just a gist of it, okay, because the next lecture is supposed to start in some time. Okay, now we've got a I'll tell you the complexity level of this problem also. You've got a sheet of charge. Okay, you've got a sheet of charge, and in front of this sheet of charge there is a rod which has got charge distributed over its length. Charge distributed over its length. So it is going to experience a torque this way. Okay, it's going to move like this. All right. Acha. Net force will be equal to 0. Whatever forces are acting on the topmost point, same forces will be acting in the bottommost point. Right. Now this is a sheet. Now since it is a sheet of charge, electric field will be equal to sigma divided by 2 epsilon naught. Life becomes a little simple because the electric field is independent of the distance. The electric field is what? It is independent of the distance. So whatever force is acting at this point, similar force will be acting at this point, which will be equidistant from this central point out here. So net force will be equal to 0 and it will only keep on rotating, right? So we need to find out what will be the torque experienced by the rod. Okay, now every point will be having the same force acting on it. Okay, because the electric field is actually the same. So if I take this small portion here, whatever force is acting on this, okay, now similarly what is going to happen? Similar force is going to act on this. All right, so it is only going to create a torque out here. But try and understand one thing. All these small portions are at different distances from the axis of rotation. Okay, so if you take this as dq, the perpendicular distance out here, let's say we take this distance as, let's say, x. Okay, so this will be equal to x sine theta. Clear? This will be equal to x sine theta. Clear? Now what you do is you take the net force to be in this direction. How much will be the net force here? Net force, I can write it as dF, which will be equal to nothing but dq into E into x sine theta. Now go ahead, integrate it. You will get option B as the correct answer. Okay, so that's all for today's session, my dear students. It's not a very difficult one. Okay, so hope you've enjoyed today's problem sessions. All right, and if you have enjoyed it, students, press on the like, share and subscribe. Very important. All right, now this also says that yes, we support you and we want to spread whatever you are teaching to as many students as possible across the country. Okay, now students, we had yet another question. Well, I keep having a lot of them, but anyways, you will get it in your PDF, so you can attempt those questions. The last question was actually on your Gauss law. Okay, it was an interesting question. Okay, by the way, you can have a look at it. If you want a discussion on this particular thing, we can interact with each other over the comment section. All right, so do not forget to leave your comments below. All right, which is very, very important because I read all of these comments, students. Okay, so who all are there in the session? I can see Shalini, I can see Rocky, I can see Nirvi. All of them are here. So something important things. So let's go ahead and discuss them. So Telegram app is important. Okay, I keep telling all my students why is it important, because you get to interact with people similar like-minded people over this particular group. You see this tiny URL.com/JEE live chat. There are so many students who have already joined this particular group. So if you have a doubt, you can just go ahead, post it. Okay, you will get your responses in a very fast time. Okay. Second thing, which I also told at the beginning of today's lecture, that is tinyurl.com/JEE mobile. You will get all the lectures in this particular URL. Okay. Next comes to your Unacademy subscription. Students, if you have not taken the subscription as yet, okay. By the way, guys, let me see your responses on the chat box. Okay. Did you love today's problems? Okay. Let me see the answers coming from your end. All right, I'm sure. Yes, very good. So you really enjoyed them. Fine. So if you've enjoyed them, you know what to do. Spread it as much as possible. That's what the key thing is. Okay. Chalo, those who have not taken the subscription as yet, very important for you students. Okay. Who are watching me live for the first time, who enjoyed this particular session. All right. Unacademy subscription. That's important. Why? Because see, most of the time the time is so limited out here. Okay, we don't get to interact as much as possible. So we are having a live session out here. Okay, like I can see Shalini and Prashu is telling me, yes, we really enjoyed today's session. Okay, but over the Plus subscription we get to interact even more. All right, whatever I teach, like, you know, we have a one-on-one discussion on that particular thing. So that's the reason why that becomes really very, very interesting. Okay, so you get to interact with the educator on and off. Okay, next thing is we have the live polls and the leaderboard. See, what happens with the live polls is you also feel motivated. There are some students who come to the platform every day to be on top of the leaderboard. Okay, so this gives them a motivation that where do they stand currently with respect to their preparation. The teacher gets to know. What does he get to know? That what is the gap between his teaching and your understanding. All right, usually this gap in the offline classes is not being handled. Why? Because all the students will look at you like this. You're teaching in the class and the students are looking at you like this. Okay, you think they are paying full attention. They're paying full attention and they're grasping each and everything that you are saying. But the real results come out when you take a test on that particular topic. And then you see the average score, not as per your expectation. Okay. So then you get to know, like, you know, yes, this is the truth. Right? Now, this gap has been taken care of when students are participating in these live polls. And we know that we taught. Are they able to answer this question now? No, let me teach it again to you. Okay, so this is the benefit of the live polls and the leaderboard. Okay, now the test series and analysis, I don't need to explain to you about this. It is pretty well defined. Live doubt clearing sessions. Take a photograph of your doubts and keep posting it. You can even snip it if you're reading the e-learning books from your Kindle. Okay, all you can do is just take a snip of whatever problems that you got faced. Okay, and you can post it and the educators will be just giving you the problem solution right then and there itself. Okay, either in between the class by halting the class in between, or let's say towards the end of the class where you can have a one-on-one discussion with the educator. Okay, students, one login and you get to interact with 60 plus educators in this particular platform. Some of the top educators, all right, are present in this particular platform and they are accessible to you through only one subscription. Remember, okay, and trust me, it's not very pricey. I mean, it's not very expensive. Okay, see, let me come to this method. We have got some steps that we need to follow here. Number one, you just search for Unacademy Learning app. Okay, once you search for it, install. Very simple. You have been installing so many things at Play Store, so go ahead, install this. Okay, once you install it, you click on plus, which will appear at the top here. Then you click on your IIT JEE, all right, and then you click on get subscription. You will come to this page here. Now this is the payment page. Okay, where you need to give money. Now interesting thing is, if you look at the payment structure, for 1 month it is 6,000. All right, but if you look at, like, you take it for 2 years, you take it for 2 years, or let's say you take it for 1 year. All right, so for 1 year it is 30,000. For 2 years it comes to 36,000. Okay, for 2 years it comes to 36,000, only 36,000. These days, due to the examination season, there's a special rate, 32,400. Use this code SMLIVE. Students, remember, use this code SMLIVE. You will right away get a 10% discount. Right away get a 10% discount. Wow, superb. Okay, who wouldn't want this, right? Okay, awesome. Fine. So you get the 10% discount. You pay only 27,000. All right. Acha. Chalo. Go ahead. Take the plus subscription. Okay. Now, I'm telling you, it's a superb thing. See, other if you see the offline coaching institutes, there are like so many of them, and institute fees have skyrocketed to some places at like 3 lakh, 4 lakh in the top cities. All right. Just compare. I mean, like, you know, the value. You will get to know. All right, by the way. Okay, so if you have not subscribed to this channel, okay, you are here for the first time, let's say, subscribe to the channel and press on the bell icon. Press on the bell icon. Why? Because if there are very, very interesting things, important lectures. Now, let me tell you, students, from April onwards, we are coming up with daily sessions. All right, daily sessions in English. For, like I told you, that JEE mobile channel, all the lectures which were there in Hindi, this year we will have all the lectures in English. Okay, super awesome lectures are going to be there. All right, you will get the PDFs. All right, remember, do not forget to like, share as well right here. Okay, if you have forgotten, do it right now as you're watching it. Okay, acha, hashtag JEE Live Daily, just go ahead and do it right away. Okay, acha, by the way, students, most important, besides this JEE English channel, we have got a NEET channel, JEE channel and foundation channel. Okay, go ahead, spread the news as much as possible. All right, and important thing, if you are still thinking and you have not made up your mind, you know what to do. Okay, go use the code SMLIVE and right away get a 10% discount, and let's meet each other at the Plus platform, where my sessions are going to start very soon. It has already started with the special classes, but very soon the courses are going to be starting off with the Plus subscription. Okay, so you get to meet me live in the Plus channel. Thank you and God bless you. Bye, and keep studying hard. Best of luck for your board exams. Bye bye.